Imagine time not as a relentless ticking clock, but as a vast flowing river. It's a concept that has captivated thinkers for centuries, moving from pure fantasy into theoretical physics. We must abandon time as an unshakable constant and see it woven with space as one fabric, space-time. This fabric is malleable, warped, stretched, and twisted by matter and energy. And it's not a trick of math. It has consequences we can measure with astonishing precision. From this insight emerge three pathways to time travel: gravity, speed, and perhaps wormholes. The first, and most established method for manipulating time, involves gravity. Mass doesn't just pull, it curves space-time like a weight sinking into a stretched sheet. Planets, stars, especially black holes, warp the fabric intensely. The stronger the gravity, the slower time flows. This is gravitational time dilation. Clocks at sea level tick slightly slower than those on mountaintops, measured and real. Orbit near a supermassive black hole, and hours for you could equal decades or centuries on Earth. Return home and you've leaped forward in time, aging little while the world moves on. GPS satellites run faster aloft and faster still must be corrected. Without adjustments, maps drift miles per day. Time's rate is local, not universal. Change gravity, change how fast you move into the future. The second key comes from special relativity. Space and time are inseparably linked. The faster you move through space, the slower you move through time. At car and plane speeds, the effect is tiny. Near the speed of light, time dilation becomes extreme. A fast round trip to a star could age the traveler years, while decades pass on Earth. In colliders, unstable muons live far longer at high speed, direct proof that velocity slows time. A real speed time machine needs sustained relativistic velocity, an immense engineering and energy challenge. But the physics is clear. Speed is a lever to control how quickly you reach the future. Combine extreme speed with intense gravity to jump thousands of years while barely aging. Gravity and speed can take us forward. To visit the past, we need a shortcut through space-time. Enter the Einstein-Rosen bridge, a wormhole connecting distant points in space-time. Like folding a sheet and punching a hole, the path becomes far shorter than the usual route. In theory, a wormhole might connect not just places, but different moments in time. Keep one mouth stationary, send the other on a high-speed trip. The moving mouth's clock runs slower. Reunite them, and a temporal difference appears. Step in the younger mouth, exit from the older one. But making and holding one open may demand impossible energy and exotic matter with negative mass or energy density. Some, like Stephen Hawking, argue that physics protects chronology, preventing paradoxes like the grandfather paradox. Wormholes solve the math, but nature may forbid the machine. The ultimate barrier to mastering time remains.